right, so let's go ahead and get started. We will continue with piecewise functions today. I think what I am going to do is your test is tomorrow. Yes, sir. Oh, you need the key. Yes, yes. But I think I'm going to go ahead and push that to Friday. I think I'm going to push the test to Friday, give us another day because I have an exit ticket that I was able to do with the other classes. I want to go ahead and do this with you guys, give yourself a little more practice, maybe some time in class if you still have a missing assignment to go ahead and take care of. So let's go ahead and do that. We'll test on Friday. Okay, and now is this the graphs of functions, sir? Okay, so you'll be grading that. Did anybody else need the key? All right, so there we go. All right, so we will test on Friday. We'll go ahead and do a little more. Hopefully, we'll finish up with this today. If not, then we definitely have the time tomorrow. On your test, you may use what? You may use your notes. Okay, so the focus activities, homework, your notes, anything that you have as a resource, other than another person, you can go ahead and use on the exam to kind of give you an advantage. Now, I do want to go ahead and talk about a couple things because we're in the third week of school and we're already getting to the point where a lot of people are missing for different reasons, school activities and things like that. And I just want to go ahead and kind of touch base again on certain expectations and responsibilities, specifically the website and tutorials. Okay, so if you're gone for whatever reason, okay, illness, emergency in the family, school activity, okay, it's my expectation and your responsibility that you go to the website and go ahead and see what's been going on while you're gone. Okay, so right now I'm in pre-cal, so let's change this. Pre-cal academic. So I already have these set up by weeks. Right now we're currently August to 27th to the 31st. Now, whatever day you're missing, you're going to want to look for those video links because the video links always have a date on there. Like, for example, what did we do yesterday? Piecewise functions. Part 1, that means we started it, but we didn't finish it. And it says August 28th, 2018. And I always try to go ahead and label the videos exactly what the notes are. Now you'll notice the notes for the piecewise functions are not here, okay, because I believe we started those the other week, or maybe we started them this week. But they're on this week right here. So if you're looking for the notes themselves, okay, you'll still be able to find those. My intention was to start those last week. That's why they're there, okay? But if you're ever gone, you have everything you need right here with the Remind app, the video tutorials, the online notes, okay? Once you've gone to the website, then I want you to come on in and talk to me about any questions you may have. So let's run through a couple scenarios. Okay, let's say maybe in your home you don't have a computer or you don't have access to the internet. Okay, there is a solution. While the library has not yet gotten their new computers, they will eventually. We do have computer labs on campus. Okay, maybe you know one of the teachers or maybe you belong to them. You can go ahead and print one of those out, the notes that you missed. Okay, maybe that's a solution. Well, let's say you don't have access to one of those labs. Okay. Well, then maybe we want to go ahead and find somebody in class. Maybe they'll be nice enough to go ahead and print the notes for you, give you a copy. Or maybe they'll just let you borrow the notes so that you can go ahead and write them down. Okay, what I'm really trying to emphasize here, the expectation, if you're gone, okay, you need to be visiting the website, okay, to stay caught up. That's what it's there for. It's there to help you out, okay? Now, you can always take a look. Now, I don't have it on the door. I don't know why I'm pointing over there. It's over here by Marcus, this little filing system. I've got 5 different folders, each different colors for day of the week, Monday through Friday. So I do make 10 extra copies of every set of class notes I make. But I want to say when everybody's here, we have 26. So that's definitely not enough for everybody. So with that, it's almost kind of like you're rolling the dice. Maybe there'll be a copy over there, maybe not. It's pretty much first come, first serve until we run out. Guaranteed, you are able to get that material from the website. Okay? Any questions about the website? Okay. Please be looking at that website. All right, now the other one, tutorials. Let's talk about it for just a second. Because again, I just want to make sure that everybody knows what the expectations are. In the mornings, 7:45 to 8:05, absolutely guaranteed I'm going to be here. That is time that I've set aside for you guys specifically. Anybody comes in, I'm going to do my best to try and answer all the questions that you have. Now, let's talk about after school. Okay, what's it say? By appointment. This is where it's going to be different. While the morning is absolutely guaranteed, the afternoon, unfortunately, is not. Okay, you have to let me know ahead of time if you're going to come in after school, because if you just walk in without letting me know, it's kind of like coming in without having visited the website. Okay, I may be on my way out the door. I may be going to a meeting. I may have something that I need to take care of. So if you don't tell me ahead of time, I don't know to switch things around so that I have time to answer your questions. Does that make sense? And I love the fact that people are coming in. I really want to answer your questions, but I'm asking, please let me know ahead of time. Okay, if it's going to be the same day, at least in the morning. Okay, let me know. Maybe I can do something, maybe I can't. Okay, the after school is not a guarantee. Now here, today I am staying after school to go ahead and help some folks who've told me they're coming in. But even the after school tutorials, they're going to be about the same length as the morning tutorials. They're going to be about 20, 25 minutes. And then after that, I may have to leave, or it'll be time to go ahead and take something else. All right, so I don't want to be in the position where I have to say, I got something going on, I'm about to leave, I can't help you. I really want to be able to help you out, but you just got to let me know. Okay, that's one of your expectations. Is everybody okay with that? Okay, any questions on the website? Any questions on the tutorials? Okay. All right, then let's see what else we got. And while I'm recording, I want to go ahead and mention it one more time. Is there anybody who has not turned in your focus activities, numbers 1 through 3? Okay, should be a guaranteed quiz grade. All you got to do is hang on to those and turn those in. All right. Well, what is happening with the test tomorrow? We are moving it to Friday. We're going to go ahead and spend one more day on piecewise functions, doing some examples, getting ready. I have an exit ticket I want you to take a look at. We'll record for a grade. We'll test on Friday, and that means we won't have any homework for your 3-day weekend. Okay, which is really good. I know a lot of people are going to be pretty bummed about that, but you know, okay. What's that?
You gave us one of the things that was due on Monday.
The piecewise?
Oh, right.
Now remember, that was not an assignment. That is just practice.
Okay.
And also, we won't have school on Monday.
My bad.
That's okay. I mean, you know, if you're absolutely welcome to come up here, but I don't think there's going to be a whole lot of folks at the building on Monday. Genevieve. I would say as long as I get it this week, let's do with that because it's just extra credit. So Genevieve reminded me of that. The assignment I gave you yesterday, which is just practice, it's just an extra resource. If you go ahead and complete it, then I'll go ahead and count that towards an assignment that you're missing. I'll just boom 100, just put it right in its place. Or let's say you're not missing any assignments. If you still go ahead and do it, I said I would what? Extra points on your exam, yes. And we always have a bonus question on the exam as well worth 5 points. So if you do that, I mean, that's even more points you could earn towards your test. Okay, so there's an incentive whether you have all your homework in or not. Okay, so either way, it's a win-win. All right, I think that's it. Unless anybody has any questions. No? No? All right, well, let's go ahead and get to it and see what we have here. We finished up with this one yesterday. We're talking about piecewise functions, and I described it as a way of basically just creating a Frankenstein graph. You want to take pieces or parts of different graphs, and you're just going to put them together into a brand new one. Okay, so we finished with A yesterday. Let's go ahead and take a look at B. Let's do the same thing. I want to create an equation for this ray, this segment, and that parabola. And then I want to go ahead and describe where the intervals are that he's contained. All right, so it might be easier to go ahead and start with where he's contained. Let's start with the parabola. So I know that every parabola wants to open infinitely wide. Is this guy going to be able to do that? No. In fact, what direction, 2 directions can he go forever? Okay, he can go forever up and forever left. Now, when we're writing the piecewise function, we only want to focus on the horizontal. So he's definitely going to go forever left, but where does he stop? He stops at 2. Okay, so this is where he wants to live, everything less than 2. So I'm just going to go ahead and say x less than 2. Do we have equality? How do we know? We have the closed circle. So I'm going to put less than or equal to. Now, I know we've really been pushing the interval notation, but when we're dealing with piecewise functions, we typically prefer to go ahead and put those inequality symbols. But the interval notation can be substituted in there just as easily. Okay, we'll come back in just a second to get the equation. So let's say this middle one right here will be this guy. Okay, so where does he want to exist? Between 2 and 5. Okay, so I'm going to say 2 and 5. So we're looking for all values of x. So I'm going to say less than, less than. See how, again, my statement mimics what the graph looks like? Okay. Do I need equality here? Why not? It's not closed. It's open circles. Exactly. And our last one here, this ray. Where does he start? He starts at 5, and how far does he want to go? He goes forever. Okay, now as the interval, we'd say bracket 5 to infinity. How would I say that using an inequality? Okay, you're absolutely right. You just forgot one detail, Brandon. There we go. He said x greater than 5. We just need the equality. Now, why did I make that equal to? Again, that closed circle. There we go. All right. Well, let's go ahead and do this. Do you guys want to start with the parabola or do the two easier ones first, the lines? Do the parabola. Go ahead and get it out of the way. All right. Now, I would go ahead and write this in vertex form. Do you guys remember that? Or does it sound familiar? Vertex form is going to look like this. Okay. For a quadratic, we have some scale factor in front times x plus h squared plus k. We call it the vertex form because these two values right here, they give me the vertex of the parabola. Oh, that was interesting. Okay. That gives me the vertex of the parabola. Now, I'll go ahead and tell you here, there has not been a dilation. Okay. There's been no horizontal, vertical stretch or shrink. So what do you think the value of A is? Okay. It's what? Oh, not 0, because what's 0 times anything? It's just 1. So in this case, A is just 1. So that's one thing we don't have to worry about. Okay. Well, let's see. Every parabola always starts at the origin. Okay. So where did this vertex end up at? Okay. I would say 0, -3. That's my H. That's my K. All right. So all we have to do is put this value into that form that we have. And because one of the values is 0, you could write it one of two ways. I could go ahead and say x minus 0 squared and then minus 3. Or I could simply say x squared minus 3. Okay. Because what is x minus 0? Yeah, if you subtract nothing, it's still x. And if I square it, it's x squared. A lot of people do prefer to go ahead and put the 0 in just so they can see the vertex a little more clearly. But what would you guys like me to put down? 0 or no? Put the 0 in? Okay. So I'll put the 0 in. If you don't want to, you don't have to. It's perfectly fine. So x minus 0 squared minus 3. There we go. So that's the equation. So if I were to graph him, of course, I get the full parabola. But remember, we have that subdomain, the interval, telling me, nope, he's got to stop at 2. Okay. Well, all right. Anybody help me out with this horizontal segment here? Yeah, it's simply -2. The equation of a horizontal line is just y equals. Okay. So all I have to do here is put -2. Okay. I mean, you could expand on that idea and include 0 if you wanted to. Does anybody remember what's the slope of a horizontal line? It's 0, right? So technically you could go ahead and say 0x minus 2. So you still have your slope and your y-intercept. But typically, we don't always put the 0. It's not needed. Okay. But you can do that if you want to. All right, and let's try this last one here. We're starting at 5. We got array. Okay, so we talked yesterday. We can either use the formula to find slope, or we can just look at it and use rise over run. What do you guys like? Rise over run? Okay. So I'm going to choose a point here. So looking at the graph, what's another perfect point on my line? Okay, 7, 4. I'd agree with that. Okay, so let's use those 2 points. So I want to go from one to the other. So how high am I going? 2. How far to the right? 2. So 2 over 2, I'd say my slope is 1. So in this case, it would just be 1x, yes. Okay. And you could just write x. That 1 is one of those things we always understand if it's not there. Okay. But if you write the 1, you know, it's okay. Perfectly fine. Now, would you like to do a little bit of algebra? Or do you, no, what, we're a math class. Or do you just want to go ahead and try to use this to see if it fits on the graph, to find the y-intercept? Okay, number 2, all right. So let's say if I'm here, I go up 1, right 1, and see how I'm on the graph? Up 1, right 1, up 1, right 1. Well, I want to go in the other direction to find the y-intercept. So instead of going up and right, I'm going to go down and left. So if I just keep going down, left, down, left, down, left, down, left, down, left. Looks like we get a y-intercept of what? -3. So the equation of that line, if you were to go all the way through, should be just x minus 3. And remember, you only see a portion of him because he only wants to exist bigger than or equal to 5. And that's it for piecewise functions. You still have the equation for the whole graph, but what follows restricts them to certain places where they want to live. Okay. Do we want to do that one algebraically just in case you ever come across one that's not on the grid? Okay, let's try it. So we know we want to put it in this form, right? Y equals mx plus b. Well, we already had found that the slope was 1. So we have that guy right there. Choose a point that's on that line. Any point on this line. 6, 3. Let's use this point right here. 6, 3. So this is an x value, and this is a y value. So if I know 3 of the 4 variables, I can easily figure out what that last one is, right? Okay. So for the y, I'm going to plug in that 3. 3 equals, m was 1, times x, we chose 6, 3, so that's 6, and then plus b. All right, well, of course, 1 times 6 is 3 is equal to 6 plus b. How would I solve for b? Minus 6. And what ended up happening? Is that exactly what we found the other way? Okay. So even if you have to do a little bit of algebra, it is still very easy to do. If you have any questions about that, please let me know. Okay. What do you guys think? Okay. Not too bad. Not too bad. Piece of cake. Because it's a piecewise function. I do what I can. All right. What? I can barely function. Did I already use the joke, I function well in my domain? Can't remember. I mean, all the classes seem to run together. So, let's see. It's math, so we always have fun. Pre-calculus, putting the fun back in functions. It's 2018. Because that's the year we're starting with. That could be our motto. Our catchphrase. Okay. Anyways, what do you think we're going to do here? Yeah, this time we're just working backwards. Here I'm provided all of the equations. I'm provided their intervals, their subdomains. I just want to go ahead and sketch it. What do you think, Nathaniel? Yes. All I want to do is sketch it. Perfect. Well, there are different ways that people like to go ahead and do this. I've already seen this year what some people do is they take all the graphs, they graph them all completely, complete graphs, all overlapping one another, and then they go back and erase the parts that they don't need. Okay? I think that's a great way to do it. I personally, though, would just go ahead and graph them in the areas they want to live. So I focus on these values here. Okay, if you're doing a problem like this, my best advice, that was weird, is use the endpoints. Use the values of those intervals to figure out what's going to happen. So let me show you what I mean. Okay, let me get back over here where I have some room. Now, the only endpoint that I see here is -1, right? Because we want everything less than that. There's no lower boundary. So we'll worry about the lower one in just a second. But whatever endpoints I have, I'm going to plug those directly into the function. And that's already going to give me an idea into what's happening. So for this one, I know x is -1, but I want to figure out the y value that goes with it. So I'm going to plug it in. -1/2 times, instead of 2 plus 4, -1 plus 4 squared plus 3. Okay. I just want to substitute and simplify. Okay. So let's run through this together. -1 plus 4. -3 squared. 9. Now it is positive because we square it. So squares it mean I want to take that number and multiply it by itself. Oh, I was just testing you. See, Lilybell's awesome. Man. She's right on top of it. Because I in no way accidentally made that mistake. It's very quiet. Okay. All right, so let's take a look. So that's 3 squared is 9. So -1/2 times 9 plus 3. And in cases like this, I would always encourage you to work with fractions because I think people always have, could use the work with it. But if you were to go decimal, I'm perfectly fine. Okay. What would you want to do? Genevieve? Okay. Is it going to give me -6? No, we're a little off. Okay. Well, let's go decimal. First off, what's half of 9? 4.5. So this will be a -4.5 plus 3. So that's a -1.5. Okay. -1.5. Okay. So we have this point right here. So at -1, -1.5. So I've marked the location, but before I actually go ahead and make it substantial, this is where you want to look at your inequality. Am I going to put an open or a closed circle there? Why closed? Yeah, we have equality, right? So I'm going to go ahead and put a closed circle there. Now, from -1 left, that's where that quadratic wants to live. He's not going to go past -1. Okay? Now, I said a moment ago, we need to go less than -1. There's no lower boundary. So just choose another value lower than -1 where we can get another point and kind of see what it looks like. Okay? Now, there's also something we can do, and I'm going to go ahead and connect it back to what we just did on a previous problem. Does anybody recognize the form of that quadratic? That's the vertex form we just brought up. Remember, here's the A, the x plus h squared plus k, right? So if you want to go ahead and create points using a table, you can absolutely do that. But sometimes you can go ahead and use a characteristic, what you know about a graph. We know that every parabola starts at 0, 0, right? Okay. Can anybody tell me what the vertex is of this parabola? Okay. The 3 is correct. Would it be positive or -4? Negative. Because think about your transformations. What direction would that 4 push in? Remember, left, because we take the opposite when we add or subtract, right? So this guy would go left, and this guy would go up. So 4 left, 3 up. Okay. Now, there's also something else about parabolas that can really help me out. This parabola would open down, right? Well, every parabola has a what? A line of symmetry that goes straight through the middle of it. Okay? So if I know that this parabola has a line of symmetry going straight through this vertex right here, in fact, let me go ahead and draw it. Okay. Well, how far a distance is that point from the line of symmetry? Looks like 3, right? So if I were to fold this guy over, his image should be 3 away as well. Okay. But like I said, if you just want to choose a value of x less than 1, plug it in like we did the -1, perfect. As long as we're able to get our sketch. Okay, so I'm going to go ahead and erase this around here. So I know that the parabola is probably going to look something like that. Okay. Now, why did he go forever on the left? Yeah, there was no lower boundary. We just want to be less than -1. So he wants to live in this whole area. But when we get to -1, that's where we have to stop. Okay. Now let's do the same thing for the absolute value. Okay. But on this absolute value, you notice the interval, we have both a lower and an upper boundary. Okay. My biggest piece of advice for these, use the endpoints. Use the endpoints to see what's happening where they begin and end. So I'm going to take this -1 and I'm going to plug it in here. Okay. So -1 something. So 3 times the absolute value of -1 minus 2 minus 4. Well, what's -1 minus 2? -3. So this is 3. Absolute value -3 minus 4. So what does absolute value do? It makes it positive. So 3 times 3 is -4. 5. So for that absolute value, the V, I know this point's part of the graph. Open or closed? Okay. How do we know open? Yeah, there's no equality there. So at -1, 5, I'm going to put an open circle. Now let's take care of that 4. We're going to do the same thing. So when x is 4, there's a y value that I want. So 3, absolute value, x minus 2. So 4 minus 2 minus 4. Okay, so let's see. 4 minus 2 is 2. But what's the absolute value of a positive number? It still stays the same. Okay, so 3 times 2 minus 4. So 6 minus 4, 2. Okay, so we have the point 4, 2. So 4, 2, right there. Open or closed? Open. There's no equality. Okay. Now you remember, what does absolute value look like again? It's the V, right? Okay. Looks just like that. Well, absolute value begins at the origin as well, just like a parabola. So let's take this point off its parent. What direction is that -2 going to push it? Okay. Why to the right? It says minus. Remember, we just said the opposite. Okay. So just like you can do with the parabola, that would be 2 to the right and then 4 down. So 2 to the right, 4 down. Okay. And this is a point on the graph, so we know it's going to be a close. Whoop, I can draw better like that. There we go. So there's my V. Now let's also think of one other thing. Does it make sense that I should have ended up with a skinnier V? What about the function told me that it should be skinnier? There you go. That value of 3 in the middle. That's a vertical stretch because you're multiplying by something larger than 1. If I was multiplying like 1/2, like I was the parabola, I'd expect the V to be what? Fatter, because yeah, you're shrinking it vertically. That's exactly right. Good, 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 good. How are we doing? Is there anybody who's not sure where I'm getting this stuff? Anything? Okay. Then we've got our last function to go. X minus 6 cubed plus 2. Okay. So very quickly, what does x cubed look like? There we go. We got some people showing me with their finger in the air. So it curves up through the origin. Looks something like that. So both the domain and the range are all reals. Okay, he extends forever in both directions. And you'll notice he goes through the origin as well. All right, so why don't we figure out where his origin goes? What's that -6 going to do? Push to the right. We take the opposite. What about the +2? Up 2. So this point at the origin has gone 1, 2, 3, 4, 5, 6, up 2. Has gone right here. Okay. Now, can anybody tell me what would be a great x value to plug in and see what value I get? Why 4? Did you just choose that randomly? There you go. Use those endpoints. Okay, use those endpoints. All right. So let me go ahead and plug that in. I'm looking for the ordered pair when x is 4. So same thing. X minus 6 will give me 4 minus 6 cubed plus 2. And I heard -2. Okay. So that would be -8 plus 2. Genevieve is absolutely right. It's -6. Okay. Now, when I put that point on there, open or closed? Okay. It is closed because I have equality. So 4 -6 would go right here. All right. Now, this is where the graph has to start because we can only be bigger than 4. Okay. See, the absolute value wanted to exist between 1 and 4. The parabola wanted to be less than -1. Okay. Now, there's no upper boundary, so we could, go ahead and choose a value and plug it in, or we probably could just go ahead and draw my curve through there. Okay. Either way, I think it would be fine. Does anybody want to choose a value larger than 6 and then just see? No? Okay. How we doing? Any questions? Anybody not sure where I'm getting these from?
When we do our point, can we put 2 points up? Or if this paper,
Yeah, I'm going to give you one tomorrow that you're going to go ahead and graph. That's the exit ticket I was referring to. As far as these go, the number of points I would really say is up to you. I would say probably at a minimum, 1. Because at the very least, no matter what, you're going to have the 1 endpoint. But if you're able to tell, what the graph is going to look like without adding additional points, like maybe here we just use the vertex and we got a really good idea of what the parabola looks like. Okay, so I would say that, the more points you put, the more accurate your graph is going to be. But no, I don't think I'll be looking for the number of points to justify the graph. As long as your closed circles are closed, your open are open, and the graph, looks the way it should, you should be good to go. They're just sketches. Okay. All right. Good, good, good. Well, we got a couple of word problems here. We'll probably be able to get through this one, and then we'll have another one tomorrow. We'll do our exit ticket because I was pretty sure we would get close, but it doesn't look like we're going to finish. And that's okay. Let's take a look at this one. It says, in the land of Leibniz, I hope I'm pronouncing that correctly, a person filing taxes as single pay taxes based on the following table. Okay, so we have our columns here. If your taxable income is at least, but not more than, then the tax rate is of the amount over. Okay, so all the information is actually already provided for me in the table. A says, write a piecewise function, t of x, giving the tax owed by a person whose taxable income is x when x is less than 125,000. Okay, so we're going to write a piecewise function, t of x equals. So we're going to write a piecewise function for this guy. All right. So we have the intervals. Let's go ahead and start. Where do you think we can begin? Okay, so the top, let's go with the top row. So what's my first interval? What's the first set that this function is going to want to belong to? Like the money that's taxable. It's between 0 and 30,000. Okay, so that's his subdomain. That's where this guy wants to live. So x is going to be between 0 and $30,000. Okay. Do I have equality? So it says at least, so would the 0 be included? Yes, so it is possible. Maybe you don't make any money, but not more than. What do you guys think? Genevieve? Okay, we're not going to include it. Okay, because you'll notice what happens on the next row. It starts to 30,000, so that's a good indicator that one's probably going to be included. Okay, so we'll get to that one in just a second. Well, X is the amount of money that you're going to be taxing, right? Okay, the taxable income. Okay, well, in this range right here, the interest rate, or the rate interest, I should say, is 15%. So how do I find 15% of anything? Change it to what? A decimal. Okay, so 0.15, right? So if I want 15% of 100, 0.15 times 100, right? But X represents my money. So what would I put here? That's exactly right. So I'll just go ahead and say 0.15x. Okay. So in this range, okay, taxable income, all I got to do is multiply that by 15% according to this table. Okay. Now let's look at the next row. What's the interval, the subdomain for the next one? 30,000 to 65,000. Okay, so let me go ahead and put 30,000, 65,000, X. So we know less than, less than. But we talked about this. Where do I put equality? On the 30,000. Okay, but not more than 65,000. So I won't have equality. Okay. And again, it makes sense because where does the next interval start? At 65,000. So that's going to be the minimum for that particular interval. All right. So if I use this to help me get the first function, what am I going to use to help me find this middle function here? There you go. Okay, so this time I have to take 20% and then add 4,500. So what expression do you think that's going to be? Okay, Christian? 0.2x plus 4,500. What do you guys think? That is exactly right. Okay. And now we have one more to go. What's the last interval? 65 to 125,000. 65, 125. Put X in the middle. So again, how is this going to work? What should I put between X and 65,000? Less than or equal to. And then to the right, just less than. But not more than, so we don't include that. Okay. And what about my expression? How much, what's the percentage we take now? Now we're taking 24%, so 0.24x plus 11,500. Okay. There you go. So according to this, however much money you make in a year, whatever interval it falls in, you would multiply that by whatever percentage and possibly add a value. That's the taxable income. So we'll go ahead and stop there because I got 33. We'll go ahead and do B when we come in tomorrow. We'll finish off the notes and then we'll go straight into that exit ticket. Okay. How we doing? Any questions? Okay. I really want to say thank you guys. You are doing fantastic. You're engaged. You're answering questions. You're doing everything I could possibly ask of you. Thank you so much. Let's keep it going. Okay. And when's your test?